All right. So again, algebraic expressions are a word statement that has been translated and expressed using literal numbers, arithmetic numbers, and signs of operations, which is a very fancy way of saying an algebraic expression is one side of an equation. Okay, it's going to have numbers, it's going to have variables, but the expression is not set equal to anything. So examples are the product of 5 and y decreased by x could be rewritten as expression 5 times y minus x. The sum of 12 and 34 could be rewritten as 12 and 34, and m divided by x is m over x. Very fancy way of saying an expression is just not an equal sign. It's one side of an equation. So evaluating algebraic expressions, usually what you're going to do is you're going to substitute numbers in for letter variables, substitute numbers for letter values, and then you're going to use the order of operations to evaluate the expression, which is PEMDAS, okay? Which is something we should remember. Okay, so here are some examples. If it says find the area of a rectangle whose length is 4 and the height is 7. Well, the first thing you need to remember is that the area of a rectangle is area equals length times width. You're going to substitute 4 in for the length, 7 in for the width, and do 4 times 7 equals 28. Now, I don't like the way this is shown, especially since the last video said don't use x. So it should be rewritten as area equals 4 times 7, which equals 28, units squared, whatever the unit is squared. Okay, second one, if x is 5 and y is 12, find 3x plus 2y over 7. This is a much better way to show it. So you put 5 in for x, 12 in for y. You use your order of operations. So 3 times 5 gave you the 15. 2 times the 12 gave the 24. Order of operations, again, means add the top. So 39 over 7, which can be reduced to 5 and 4 sevenths. Those are just some quick examples of substitution in algebraic expressions. And lastly, some key points we want to make note of. If there is no arithmetic number before a literal number, it is assumed to be a 1, which is a fancy way of saying if we have a plus b plus 3d, assume it's 1a plus 1b plus 3d. So no number in front, it's a 1. Only like literal numbers can be combined. So if we have a plus b plus c plus a plus c, well, we have 3 a's, which is why we have the 3a. We have 1b, which is why we still have 1b. And we had 2c's, which is why we have 2c's, combining like terms.